Unloading of materials from dry bulk trailers is done through pneumatic conveying lines on the trailer and transport pipe at the unloading site. Either a truck-mounted or on-site blower provides conveying air to pressurize the trailer. When the discharge valves are opened, the velocity of the airstream is increased and pneumatic conveying begins. There are different phases of pneumatic conveying, and each material has unique characteristics that determine what air volume and line velocity is required. Dense phase conveying is much like an extrusion process where low air velocity is used to push material through the unloading line. It is used over short distances for materials like cereal, where avoiding product breakup and degradation is required. As air velocity increases, there is a point where particles are picked up and carried into the airstream. This is referred to as the particle pickup velocity. This velocity, which is unique to the material being conveyed, must be exceeded to convey a product in dilute phase. Dilute phase conveying allows powders like cement and flour to be conveyed over longer distances. Saltation velocity, which is the air velocity at which particles begin to fall from suspension, is also important. When air velocity is reduced below the saltation velocity, particles begin to collect on the bottom of the unloading line. If the velocity is decreased further, the product will continue to collect and partially fill the pipe in heaps, similar to sand dunes. During intermediate or mixed phase conveying, these heaps may move along the pipe. Because the open area of the pipe is reduced, the air velocity increases, causing the air to pick up more material. Conditions then become unstable, but the flow becomes self-regulating and plugging is unlikely to occur. Material characteristics are not the only factors important to efficient pneumatic conveying. Other factors that affect unloading include tank pressure, which is limited by regulations and is normally 15 psi, 1 bar, in the United States, line diameter, which allows for more area for material to be conveyed, and unloading line length, when doubled, can reduce the unloading rate by as much as 36% for products like flour and cement. In practical applications, the factors affecting unloading and transport through a pipeline can be summarized by operating zones. The plugging zone is where material plugs the line repeatedly. The slugging zone is where insufficient air volume causes the line to stop and then start for a short while. The surging zone is where the flow slows, then speeds up repeatedly. At this point, the risk of plugging is low, resulting in the maximum unloading rate. The smooth zone is where the unloading is trouble-free with no risk of plugging. And finally, the vibrating zone is where air volume is excessive, resulting in slower unloading, unnecessary pipe abrasion, and product degradation. Longer unloading lines require higher air volume to achieve optimum unloading rates. For example, with a 4-inch line, the optimum airflow volume is 15 psi using 1 bar pressure. For a long line, the optimum air volume increases about 70% to 380 SCFM. Dry bulk tanker drivers often do not have a choice of the delivery line at the customer location. Drivers should learn to optimize air volume for the product being delivered by reducing the line length whenever possible, using the shortest delivery hose, and maintaining full tank pressure. Engineers designing unloading terminals should avoid inclines, extra bends, and changes in pipeline size to avoid plugs. While flow characteristics vary by product, there is one constant when unloading your trailer efficiently: no clogs, no maintenance, no material left behind. Learn more why nothing unloads faster than Solimar aeration.